Welcome back to Cypress Academy, PSoC 6 101. In the video 3.3a, I showed you how to use a PSoC 6 BLE to build a BLE central that can control a project from 3.2, the simple BLE peripheral LED dimmer project. In this video, we're going to start building a complete BLE remote control for the robot arm. When the remote control is done, you will be able to use the UART to type keys to control the robot, the CapSense, as well as the Bosch motion sensor to control the BLE robot. I think that I will start this project by making a copy of the project from video 3.3a and start carving it up. Let's start by editing the schematic. Open up the BLE component customizer. Go to the GAT settings and delete the LED service. Then add in the motor service by right-clicking on Client, Add Service from the file and picking the file for the motor service. Now run Generate Application so that we get all of the BLE updates into the middleware and generated source. You are going to get a bunch of errors, but don't worry about them for now. We'll get them fixed up. All right, now let's carve up the firmware into a more manageable structure. I'll follow the template that I've been following in the main controller, meaning I'll have the BLE stuff isolated into the BLE task.h and the BLE task.c. And I'll have a UART-based controller in UART task.h and UART task.c. So start by making a file called bletask.h. I know that we're going to want to send messages of changes to the motor positions. So let me make an enum with the motors. I'll also make an enum so that I can specify whether I want an absolute or a relative motor position change. Now, let me create the prototype for the function that will make the motors move. When I call that function, I'll send it a motor number, a change type, and a %. The last thing I need in the BLE task header file is a definition of the task. Next, I'll make bletask.c by right-clicking the source files folder and picking Add New Item, C file. I'll call it bletask.c. Let's add in the includes that we need. Now I'm going to go to main cm4.c and move from the top of the right LED function through the end of the BLE task, and I'm going to move all of that into bletask.c. I'm going to modify the right LED function, so I'll copy the function prototype from the BLE task.h and replace the right LED function declaration. Instead of brightness, let's print out information about the requested motor movement. If you recall from the previous video, in order to write, we need to know which handle to write to. If you remember from the BLE motor control service, there's 4 possible handles that we're interested in: M1, M2, M1 relative, and M2 relative. When we do the service discovery, our BLE stack will discover those characteristics and build an array of handles for those characteristics called CYBLE custom cserv which service dot custom serve characteristic which index dot custom serve care handle bracket 0. Wow. So in order to figure out the handle, we need to do 4 if statements that look up the correct handle based on M1 or M2 and relative or absolute. After that, you assign the % to the right variable, then write it using the CYBLE GATC write characteristic function. Now I need to change the scanner to look for the motor service instead of the LED service. I'll change the comment, then the index, and finally the printf message. When I wrote this code originally, I was lazy and didn't put in the BLE semaphore. So let's fix that. First, I'll add the semaphore to the top of the file. Then I'll copy the interrupt service routine and BLE task from the previous BLE project. And I'll paste it into my BLE task.c. And finally, I'll chop out the stuff about the events groups. Now we have a nice generic BLE task handler. Now I'll make the file UART task.h. This file will only have the pragma once and the definition of the UART task. One more cheat. I'm going to just copy the UART task from the BLE main controller into my project, since it's almost exactly what we want. First, add BLE task.h to the top. Then I'll add my key commands for O, P, J, and L that will just call the right motor position function, which I will also add to the help printout. Okay, program your development kit. When I look on the UART, it starts searching for devices like crazy. And quickly you can see that it finds the robot and both connection lights turn on. Now when I press the O and the P buttons, you can see the arm move back and forth. Sweet! Next time, we'll add capsins to our robot. You can post your comments and questions in our PSoC 6 community, or as always, you're welcome to email me at alan_hawse@cypress.com or tweet me at AskIoTExpert. All right, thanks guys. I'll look forward to talking to you in the next video.